Okay, hello. I'm Jovel Kalawalatian and this is my video presentation about the theory of discrete time, signal, and system. So first, what is discrete time, signal, and system? So discrete time signal is a time series consisting of a sequence of quantities, a sequence of values that correspond to particular instant in time. The time instant at which the signal is defined are the signal sample times, and the associated signal values are the signal samples. So traditionally, discrete time signal is considered to be undefined at points in time between the sample times. So let's recall the basic block diagram of DSP. So signal in, the analog to digital converter, digital signal processor, and digital to analog converter, and signal out. So this is the figure 1 basic blocks of DSP system. So what is digital signal processing system? Let's start with the individual meaning of words, defining digital signal processing in its entirety. So, first, digital. In digital communication, we use discrete signal to represent data using binary numbers. And the next one is signal. So, what is signal? A signal is anything that carries some of information. It's a physical quantity that conveys data and varies with time, space, or any other independent variable. It can be in a time, frequency, domain. It can be one-dimensional or two-dimensional. Here are all the major types of signal. And the second one is processing. So the meaning is the performing of operation on any data in accordance with some protocol or instruction is known as processing. And the system. A system is a physical identity that is responsible for processing necessary hardware to perform the required arithmetic or logical operation on a signal. Here are all the major types of system. So if we put all this together, we can get a definition of DSP. So what is digital signal processing? The DSP. So digital signal processing is the process of representing signal in a discrete mathematical sequence of number and analyzing, modifying, and extracting the information contained in the signal by carrying out a logarithmic operation and processing on the signal. So DSP is a process of analyzing and modifying a signal to optimize or improve its efficiency or performance. It involves applying various mathematical and computational algorithms to analog and digital signals to produce a signal that's of higher quality than the original signal. So what signal? Signal needs to be processed so that the information that they can contain can be displayed, analyzed, or converted to another type of signal that can maybe used. In the real world, analog products detect signal such as sounds, lights, temperature, or pressure and manipulate them. So converters such as an analog to digital converter then take the real world signal and turn it into the digital format of ones and zeros. So from here, the DSP takes over by capturing the digitized information of processing it. Then it then feeds the digitized information back used in the real world this is one of two ways, either digital or in analog format by going through a digital to analog converter. So all of this is a course of very high speeds. Then signals in the real world, signal which is continuous time form. it will be converted into digital form using ADC. And the output of ADC is of course a digital signal. So these are specifications that ADC requires for it to produce the necessary form understandable by the digital signal processor. So first is sampling frequency, and second one is sampling resolution. So what is ADC? An ADC converts continuous time and continuous amplitude. So analog signal to discrete time and discrete amplitude digital signal. So the conversion involves quantization of the input. So it necessarily introduce a small amount of errors or noise. So furthermore, instead of continuous performing the conversion, an ADC does not conversion periodically, sampling the input, limiting the allowable bandwidth of the input signal. So I have a graph below. So this is a continuous time signal in order to analyze a signal in certain points of, for example, we take the values of the amplitude to those points at the y-axis with respect to time, which is the x-axis, as shown in figure 2. The values of y at the time x is equals to 0.2, 0.4, and 0.8 is defined. So this is the figure 2. This is the waveform of continuous time signal y equals sine omega t. So generated in MATLAB. So but what if we have a lot of points we want to analyze? It is not practical to do it in unequal intervals. The best option is to divide it into several points. In this way, we can analyze both of the discrete value at that point. So I have figure 3. This is the waveform of discrete time signal. Y equals sine omega, and this is generated in MATLAB. So causality is also used to describe a system. More of this in topics about transform. So what is discrete time signal? Discrete time signal may also be represented by sequence of number, but the upper and lower limit must be defined first, using the lower limit to 0 and the upper limit as positive infinite is referred to as causality. So a causal signal will neglect that values at the negative side. If both sides are considered, then the signal is called anti-causal. So those values which are in place before 0 are considered advanced, while those which are after 0 is considered delay. Then this is the figure 4. Oh, sorry. This is a This is a unit sample signal generated in MATLAB. So as you can see, this is pointed in 0. The line is in 0. So, example, represent the following signal graphically for x1, n equals delta n plus 0.5 delta n minus 1. So the solution is here in the figure 5. A sequence of impulses generated in MATLAB. So another commonly used type of discrete time signal is a unit step signal. Notice it is a train of unit impulses which is theoretically infinite. So this is the another figure 5, a train of impulses called unit step generated in MATLAB. So this is the exercise. Graphically represent the given by x2n equals un minus delta n. So the solution is in the figure 6. So difference of the unit un and the unit sample with no delay, and delta n is equals to a unit step with one delay, un -1 generated using MATLAB. So the graph represent a unit step signal, while the second represent the unit sample. The third represent the difference between the unit step signal and the unit sample with no delay. Result unit step with one delay. So sampling frequency. So according to a sampling theorem, also known as a Nijist theorem, named after Harry Nijist, it states that for a signal to be a proper constructed, a signal must be sampled twice the maximum frequency component of the signal. So trying to sample a signal under the requirement of the sampling theorem will cause distortion called aliasing. So practical application of sampling resolution. So in practice, audio signal are sampled at 8 bits, 16 bits, and 24 bits. So both the sampling frequency and the sampling resolution allow the signal to take the waveform necessary for reconstruction. So a good sampling frequency will allow the signal to be properly reconstructed. The number of bits is dictated by the numbers of gradation of amplitude to represent the levels of a signal. So high resolution will allow the signal to take the desired waveform. In other words, providing adequate sampling frequency and high resolution will produce the best result. So this is my example. The Nijist frequency for the signal xt equals 3 cosine 50 pi t plus 10 sine 300 pi t negative cosine 100 t is, the answer is 300 hertz. So my explanation is, we know that the Nijist frequency is twice the maximum frequency. Fs equals 2 fm or frequency modulation. The maximum frequency present in the signal is omega m equals 300 pi or fm equals 150 hertz. Therefore, the Nijist frequency fs equals 2 fm equals 300 hertz. This is my second example. Then the Nijist rate of the signal xt equals 1 plus cosine 2000 pi t plus sine 4000 pi t, and the answer is 4000 hertz. So explanation, given xt equals 1 plus cosine 2000 pi t plus sine 4000 pi t. So the highest frequency component is 1 is 0, and then the higher frequency component in cosine 2000 pi t is omega m1 equals 2000 pi, and the highest frequency component in sine 4000 pi t is omega m2 equals 4000 pi. So the maximum frequency component is xt in xt is omega m equals 4000 pi. So the highest of 0, 2000 pi, 4000 pi. So 2 pi fm equals 4000 pi, 2 fm equals 4000. So the Nijist rate fs equals 2 fm is equals to 4000 hertz. So that's why the answer is 4000 hertz. And this is my last example. Find the Nijist rate and Nijist interval for the signal ft equals rect 200t. So infinity hertz, 0 sec. So my explanation is, given ft equals rect 200t, which is the rectangular pulse signal having a pulse width of 200 seconds. Since the signal is a definite duration signal, it is not band limited. The signal's spectrum consists of infinite frequency. So, Naige's rate is infinity and Naige's interval is 0. That's why it's 0. And that's all, and thank you.